Good afternoon, everybody. Thank you for the organizing committee to give me the opportunity to present this new application of protease during vinification to achieve the protein stability in wine. As you know, protease are natural enzymes that are broadly used in the food industry. Those enzymes are catalytic proteins able to hydrolyze the peptidic bond in proteins. They are broadly present in living organisms. They are involved in the main function of living organism, like in digestion with digestive enzymes, pepsin, trypsin, or chymotrypsin. They are also involved, for instance, in the blood coagulation with thrombin, and even in the regulation of virus infection with the presence of serine protease on the surface of our cells. You have here in the slide the various structure of the protease I mentioned, and you have also know that those protease are strongly expressed and secreted by fungi during the pathogenous infection of vine or other plants. The action mechanism of protease could be quite simple, and actually we classify the protease in three different categories, depending on the location of the cleavage on the protein chain. You have two types of exopeptidase, carboxypeptidase that cleave the protein on the C terminal peptide, or aminopeptidase that cleave the protein on the N terminal peptides, and also endopeptidase able to cleave the protein inside the proteic chain, and the cleavage is located on special amino acids depending on the protease. In terms of classification and EC classification, you know that this EC classification is broadly used for enzyme in the industry. Those enzymes are classified from EC3411 to EC499, depending on their specificity. The use of protease in the food industry and the non-food industry is an old story, and the proteolytic process has been used and exploited for years, like for the production of cheese using rennet, which initially come from the stomach of the bears. This rennet is a complex mixture of the different enzymes, but chymosin is the main enzyme that is responsible for the milk coagulation due to the hydrolysis of the casein. This is an endopeptidase, hepatic endopeptidase, and now chymosin can be also produced from Aspergillus niger culture. Malting during the brewing process is also an old process involving protease, and it's a completely natural process. During the germination of barley, which is the key point of malting, there is a secretion of various enzymes like amylase, responsible for the hydrolysis of starch, but also proteases that can hydrolyze partially hydrolyze the proteins of barley with the liberation of amino acids, which is helpful for the further fermentation, but also helping for better solubilization of proteins to help the beer form stability, but also responsible in some case of haze formation. If we have a general view of the use of protease in the industry, you can see that in the non-food industry, protease are produced and used for detergents and also for the leather production. They are also used to process keratin-based cosmetics. And in terms of laboratory analysis, proteases are used to determine the composition in amino acids of various proteins. They are also used in the pet food processing to produce food with a high digestibility and also nutrient supplementation for a better digestion of the food. In the human food industry, they can be used also for nutritional aspects, but also for the decreasing of allergenicity of some food, like peanuts, the production of bioactive peptides, production of cheese, to get the meat more tender, and obviously during the beer processing to avoid haze formation. The use in the wine context has been documented for years, but at this moment there were many issues. The first one was the wine acidity, and to avoid the loss of efficiency, it is necessary to select and to produce an acid protease which is active at the wine pH. The second issue was that the globular conformation of chitinase and tomatin-like protein that are responsible for the protein instability of wine limit this globular for conformation, limit the efficiency of protease, since the active sites are not accessible due to this conformation. And the third issue was and is still a regulation issue, because this activity, protease activity, is not yet allowed by OIV regulation. So the various options to bypass those issues are the selection of acid protease and aspergillopepsin 1 and 2 from Aspergillus niger, or bacillopepsin from Bacillus liquefaciens could be a good candidate since they are acid protease. To avoid the loss of efficiency due to the conformation of the unstable protein, the introduction of heating step with the enzyme has been proved to be the solution and due to the unfolding of the protein, those proteins with eating are accessible to the enzymatic activity. And for the regulation issue, we started discussion and approbation process inside the OIV organization since 5 or 7 years. In the next slide, I will share with you some technical aspects general to the protease use. And you likely know that proteases are known to be mainly active at high pH, and that was the problem for the wine application. You have here some example of industrial protease, and only some of them are acidic protease. So we have to do an accurate selection to have those convenient acid protease for the wine application. The second issue was the globular conformation, and in order to avoid this problem, the use of a heating step is a convenient option, since it is led to the unfolding of the protein. This unfolding is a non-reversible process for the chitinase, but for the tomatin-like protease, it's a reversible process. So the enzyme should be added before the heating to avoid the turn back of the protein to the original conformation. You have here some example of the efficiency of aspergillopepsins for the degradation of protein in wine. In the graph on the left, you can see that just eating can help to reduce the global protein content of wine, but eating with the addition of aspergillopepsins is the only way to roughly completely degrade all the proteins, and especially the unstable protein, as you can see on the graph on the right, the complete degradation of TLPs and chitinase using eating and addition of protease in the red you have the red curves. More recently, application of aspergillopepsin on Gewürztraminer, which is a very unstable protein, give very good results, and with an efficiency comparable to the addition of bentonite. And you can see here with the green arrow the efficiency of bentonite at 60 grams per hectoliter, and the efficiency of this aspergillopepsin after eating at two different dosage, 1.5 or 2.5. So this application of protease is efficient as the bentonite treatment. The first question you can have because of this compulsory eating step is, what is the side effect of eating in terms of qualitative and aroma profile of the wine? And I give you on this slide two examples. The first one from a publication from Matteo Marengon on Sauvignon Blanc in Australia, with a heat treatment of 75 degrees for 1 minute. And you can see that there is no difference between the bentonite treatment and the heat treatment only, or heat treatment with enzymes, in terms of aroma profiles. We did similar treatment and application on Chasselas in Switzerland with heat treatment at 70 degrees for 1 minute. And you can hear that in this case, no significant difference between the control without any heat treatment and any enzyme, and in the second line of the table, the heated and enzymatically treated sample. So we can assert that there is no negative effect of this heat treatment if it's done in the correct condition. No effect on the aroma profile of the wine with or without addition of protease. The second question is the question about the residual activity of protease between the treatment that could disturb other fining treatment using proteins. And actually, in the same study we did in Switzerland, we quantify the residual activity in wine treated or not treated with different enzyme, and in there is no residual activity at significant level in the treated wine. You can see on the graph that in filtered or non-filtered wine, the residual protease activity is in enzymatically treated samples in blue are at a similar level than the control wines in red. So no problem in terms of further fining treatment. No problem for the use of protease. What about the regulation? So the discussion is still, the application is still in discussion in OIV, but those protease are broadly allowed in the food industry all over the world. It's a product, an enzyme that is recorded in the Codex Alimentarius as an additive. It's already approved by the FDA in the US to stabilize wine and juice and to eliminate the unstable protein. And Aspergillus niger and Oryzae, that are the main microorganisms producing protease, are recorded as safe by the GRAS regulation. Those protease are also allowed by the Australian and New Zealand regulations, also the Canadian regulation. And in Europe, those protease are already approved in beer, brewing, bakery, cheese processing, fish processing, juice production, and protein processes. And different AMFED dossiers have been validated by the European Authority for Food Safety, involving bacillolysine and aspergillopepsin. In the OIV, two resolutions are still in discussion. The technical resolution and the specification resolution, but we already get the approbation of the Safety Commission only for aspergillopepsin 1, and with the compulsory step of the eating step as compulsory in order to have the the proper efficiency of the enzyme, but also to degrade the enzyme after the treatment. So we are at the final step for approbation, 5 for technology and 3 for specification. In Oenobrands, we already developed a liquid formulation of protease, which is an aspergillopepsin 1 as required by the discussion, the resolution in discussion in OIV from Aspergillus niger. This enzyme is in line with the specification currently in discussion. And we tested and validated this enzyme during a different study performed by Enopia and also performed by our own company. Here are some data coming from our trials. We advise to use this protease formulation, which name is Proteostab, on must, using for the heating step a thermoflash pasteurization equipment, or the first step of a flash detonate equipment. It can be used on white, rosé, or red wines. And you can use only rapidase Proteostab to achieve the protein stability. And you have here on the right, the first graph on the right, the efficiency of Proteostab. You can get eating in here is able to reduce the protein instability, but not we're at a sufficient level, whereas addition of Proteostab at 3 milliliter per hectoliter and eating is able to reduce the instability, the wine instability at the right level. You can also combine the use of this protease with a thermoresistant pectinase and then achieve both protein stability, but also clarification in the same step during the heating step. And you can see here in terms of turbidity, so the clarification process, that the use of Proteostab and heating is already able to reduce the turbidity of the must. But if you add a thermoresistant pectinase, you achieve a very good clarification with the protein stability. We already built some protocols for the application in white and red wines. And you have here the example of the application of protease in white with skin contact or without skin contact. And also because we already have the question, we can use this protease during red vinification, and especially with heat treatment, flash detent, or thermovinification, since some wine buyer required wine without any protein, residual protein in the wine. So with the use of rapidase Proteostab and rapidase thermoflash and the heating step, you can achieve a complete deproteinization of the wine and a good clarification and filterability of the must after pressing. So if you have some question, you can add them to our exclusive distributor in Spain, which is Vason Ibérica, and Anna will be the right contact, or our area and brand manager, Antonio Alamo, located in Spain, that could also give you further details on this new enzyme and coming soon application. Thank you very much for your attention.